That was fast. All right, so I was talking about over here. Yeah. I mentioned this thing called I/O controllers, right? And I alluded to something called an I/O processor, but I didn't actually put it up here. And I took the slides out of this semester's, but I think we should just go ahead and introduce it anyway. Okay, because the I/O controller does exactly what we were talking about. It's doing stuff that we would code in the device driver, which we're going to talk about in more detail later, to do that translation for us to the actual RD electrical signal translation, right? So the I/O controller is talking directly to the same like devices. So if this was a UART, this was also a UART, this is also a UART. Okay? I would have a separate I/O controller for USB, and I can have a whole bunch of USBs. In fact, USB is a great example because if I had an I/O controller managing a whole bunch of USBs, then I have some issues I'm going to have to deal with. Primarily, the I/O controller is going to run out of time to manage all of these different USB devices. Right? Yes?
You can have like one cable connect USB, and then there's another like 5 more slot to connect, another USB outside. You know what I mean?
So on one USB here, I could connect it to a USB hub. Which would break this one channel out into 8 more or more. Yeah. I could get a whole lot of USB devices. And if all of those USB devices were talking to one I/O controller, then I am restricting the speed that the USB gives us, right, to whatever it is I can process at any one device at any one time. So USB was a great, actually it came after this I/O processor concept, but it's a great illustration as to why we need something more advanced than a simple I/O controller to do. So we came up with this other device, which we will call an IOP, or input-output processor, which kind of use the same logic that we use for DMA controllers. Hey, all those 486 chips that are just laying around that no one's buying these days, slap them in here, put a little processing work on them, make them smart enough to be able to do things like switch between different devices quickly and move blocks of data even, not just streaming bytes at a time, but moving blocks of data through here, is a huge efficiency. And so that's what the I/O processor is going to do. It's going to take a processor, it's going to know a little bit more about these I/O transfers so it can handle things like a block transfer, whereas an I/O controller can only handle a string transfer. You could do it like a block transfer, but it's going to translate at signal level to a byte, because that's what an I/O controller can do. But an I/O processor can truly handle blocks at a time. Okay, so one of the biggest differences, of course, is that that logic has to be built into this processor itself. That's okay, these processors have all kinds of param memory space on them, so you could program what a block transfer is. Of course, at boot time, one of the things the operating system has to do is it has to tell the I/O processor what size are my blocks. Right? So then all I/O processors on this runtime instance of this OS will do the same size block transfers, although you can write some systems code to change those sizes of blocks if you want to, but that's kind of getting ahead of ourselves. Okay, so the concept of an I/O processor came about long before actually DMA controllers did. And it gave us that power for doing these block transfers because I could program that into the I/O processor, as well as letting it switch between devices that it's managing. Now, because we know that, sure, I can build this, but we're still talking on a single bus here, so we recognize that if I get too many I/O devices, I'm going to have lots of collisions on this connection, right? So typically, when you look at your architecture of your particular system, you will see multiple bus controllers for your USBs. Your USB interface may have like 3 or 4 bus controllers, USB bus controllers built inside of it, and that's to enable you to create faster throughput by putting fewer of these USB I/O devices on any one USB controller I/O processor.
What about Bluetooth? You know, you have like the keyboard Bluetooth,
Mm-hmm.
and then you can connect to it, and then
Mhm.
you just press.
Yeah, Bluetooth is more analogous to a modem than it is to this. Yes, we will still have a modem interface that it's going through that understands the Bluetooth protocol. It will have its own I/O processor, an I/O processor that understands Bluetooth. In some cases, the I/O processor will understand Wi-Fi and Bluetooth, so it handles 802.11 in addition to Bluetooth. Some I/O processors are built that way. And they just recognizing that you're going to have very few devices, and they just program it that way. Depends upon that manufacturer. But each protocol will have to have an IOP either dedicated to it or that understands that protocol and is built into the problem for that particular I/O processor. Okay? Questions? No, because we're hot and we want to go home because you said we could. Okay. That